GSP TecHub will be, by the special grace of God, we're going to be starting this training. We're having this training in time past, but we're resuming now. So, but the purpose of why we're here is to learn data analytics. And because we understand that there's need for us to have the fundamental knowledge of data. So much of what we're going to be doing today is going to be theory. All right, we're going to be taking us through what you need to know, what you need to understand about data. All right, so there's going to be much of talk today. Please bear with us. We need to ensure that the knowledge is, your mind does not resist the knowledge. So you need to first understand what it is. Okay. Then the next class will be practical. We're going to teach you on how to use SQL, right, to run data. Then the last class is going to be visuals and Power BI. Also, is going to be practical. All right, so you need to learn how to create visuals. I'm sure most of us, all we've seen about data analytics is the Power BI dashboard, isn't it? You like the graphs, you like the numbers and all that. So that's going to be the last course. But for today, we're going to start with the introduction, which is going to be Data Analytics 101. So it is with my utmost appreciation to welcome our wonderful brother who is going to be taking us through today's class and the next class. So please let us put our hands together for Mr. Oyejide Oyevide. Most of you have seen him before. Is our drumstick, Jide stick. Hallelujah. So he's also a tech bro. Jide, please come and take over. Hallelujah.
Thank you very much, Sir David. Good morning, everyone. My name is Oyejide Oyerinde, also known as Jide Loops. That's just outside. Yeah. So it's a privilege to be here. I hope my voice is audible enough. Right. Okay. So as Sir David rightly said, it's always important that we start from the basics. We know this class is like a class of mixed people. Those that are just starting out, those that are just hearing of data analytics for the first time. I'm sure people are just hearing of data engineering for the first time today. There's always been data analytics, data science, data analytics, data science, but data engineering is also equally important. So this class is just, as I said, it's going to be like a brief introduction. Towards the end of the class, if we have enough time, we might just touch basic SQL. I can see that most of us came with our laptops. Those that are with our laptops, fantastic. Those that didn't come, again, knowledge is always good to just listen and just gain one or two things. So we'll just get to it now. Okay. So as we said again, the topic is exploring the basics of data analytics, engineering, and science. So let's go. So I'm sure you've been hearing of data, like for the past maybe 6-7 years now, right from COVID time up to this moment, we've been hearing of data. So I want maybe 1 or 2 persons to just tell me what they understand by data. Yeah. Stylary, do you want to help us? Okay. It is well. Okay. First off, is anyone in data? Like, is anybody doing like a role currently in data analytics now, or you're just starting out? Okay. See young people here. Okay. Before we go into that briefly, before we go into that fully, maybe we should just do a brief introduction. So I would like an idea of the target people in this class, so I understand where to start from. Yeah. So, bro, what's your name? Favor, okay. Music, oh, fantastic. Oh. Interesting. Favor, right? Young man. Maxwell, okay. Still a student, right? Okay, secondary school. Okay. Oh, wow, okay. Good. Catching them young. Maxwell, right? Mark, please. Delapo, okay. HR services.
This would be good for me. Thank you, sir.
Okay.
I think this would be good for me because you need to put together data of clients,
HR,
recruitment, and all those things.
Okay, fantastic. Thank you, Delapo. Hello.
Yeah, good afternoon.
Good afternoon.
My name is Itizo. I'm currently employed
Okay.
and just want to dive into the
Data
tech,
field. Okay.
tech sector.
Interesting.
Good morning.
Good
My
morning.
name is Ibuka.
All
I'm
right.
currently into cybersecurity.
Okay.
Well, I wanted to get an idea of how data analysis works.
Oh, fantastic. Okay.
My name is Fee.
Yeah?
My name is Fee.
Fee, okay. Currently a student. Right, okay. I see you have lots of young chaps there.
My name is Oluchi.
Oluchi, okay. Students also, okay, good. Just let me pass the mic.
Good afternoon, everyone.
Good afternoon.
My name is Isaac.
Isaac. Okay.
I work for a food company.
Okay, for
So I'm
okay,
trying
okay.
to get insight into what
What's in data analytics? Okay, fantastic.
Yeah, good afternoon.
Good afternoon.
Yeah, my name is Bolaji, and I work in an accounting firm.
Any
Accounting firm.
accounting firm? Oh, you play with data, I don't.
Good afternoon, Ola.
Hi,
Samuel,
okay.
pharmacist by profession. I want to know more about data.
Okay, fantastic.
I'm Hilary,
Okay.
into agriculture and about data.
Okay. Fantastic. So I see we have those that are newly just starting in this field. So again, let's just proceed. So on my first slide, I have what is data. So data is like a buzzword. It's like almost everywhere. People just keep saying, oh, data analytics, data. But sometimes people don't have a fundamental understanding of what data is truly. So as I have here, I said data refers to raw facts, figures, and details collected from various sources, which may represent anything from numbers, text, or even multimedia, that's images, videos, etc. So on a daily basis, human beings, we are exposed to a lot of data. So data is usually in its raw form. You have to process it before you now get information out of it. But on a daily basis now, you might just be on your way out and then let's just paint this scenario, for example. You are going to work, right? And you wake up in the morning, then you check a notification on your phone. The phone says, oh, it is going to rain. Normally, if you see that kind of information, you might take it passively. You might not commit it to act. So if you go out without your umbrella, what's going to happen? You'll be wet. So you can see that data is almost everywhere you are. If, for example, you are traveling, let's say you're trying to get to Ojota now. I know most of us on the mainland, we know there are like two routes to Ikeja rather. You can either follow Third Mainland Bridge or Ikorodu Road. If someone tells you that, oh, on Ikorodu Road, there's like some sort of traffic, you can follow Third Mainland Bridge and take you a shorter traffic time. You might just decide to say, no, I want to follow Third Mainland Bridge. At the end of the day, what's going to happen? You'll be stuck in traffic. So data is always everywhere around us. It's everywhere around us. In the pictures we see, in the videos we see, when you're on your mobile. Data, when it is unprocessed, is not powerful. Like you might just be seeing data every day. You might not know what to really do with it. But at the end of the day, when you process it, it becomes information. Like, maybe I should just draw that up here. So you have data here, right? If you don't process it, there's like a processor here. Sometimes for human beings, usually our brain that processes that piece of data and then it turns it to an information that we now make decisions on, informed decisions on. So basically what I'm saying is every day, everywhere, we always have data around us. It's usually noisy. There are lots of information, data, don't let me call it information. Data flying up around, flying everywhere. You don't really know, if you don't try to process it, if you don't process it and make a piece of information from it, it might eventually harm you one way or the other. Do you get? And we have different types. So let's just proceed. I think my second definition here is, it is usually unprocessed information that when organized and analyzed can provide meaningful insights. Just like the example I gave earlier about you waking up in the morning, checking your mobile phone and seeing that, oh, the weather app on your phone is telling you that it's going to be a rainy day. It's still like an unprocessed information, right? What do you do to it? You have to first analyze that piece of information. You are seeing it on your phone. Am I checking the right date? Am I in the right location? Is this weather app updated? Those are the kind of things you have to, that comes in the organization and analysis stage. Then out of that, after you've done all of that analysis and then organization, you can now come up with a meaningful insight that eventually gives you an informed decision. You can now make a decision out of that initial crude data that you have. So I hope that makes some sort of sense to us. Are we on course? Okay. So basically, we have 3 types of data. Data is usually classified in 3 core forms. We have structured data, unstructured data, and then semi-structured data. For structured data, the data is usually organized in a fixed format. And I'm sure most of us, has any of us ever worked with Excel before, or maybe data in a table? You've seen it before. How is it usually organized? It's organized in rows and columns. That is a structured data. It is easier for you to analyze a data that is in a structured format. Do we get that? So most times, examples of that kind of data is Excel spreadsheets, could be your CSV files, could be your Excel workbook file, your worksheet file. Most times that data is usually in 2D formats. And when I say 2D formats, what I mean is it's usually in rows and columns. So for example, you can have name here, you can have name, you can have age here, you can have gender here, and anything, maybe serial number here. So it's usually structured. It's usually in rows. When I was younger, I used to make mistakes with rows and columns, but yeah, I'm sure you've experienced that kind of thing before. But this is a column. This is a column. Column is talking to this individual data here. So anytime I look at this Excel worksheet, what I'm seeing is the serial number. Whenever I'm checking this column, I know what I'm dealing with is the name. So it will be odd for me to be seeing, maybe under name, I'm seeing 15. You would know definitely that's not the right here. So again, it's easier to sort or work with structured data. If somebody gives you a worksheet of maybe, let's say, for example, we gather all the data of everyone in this class, our age, our name, and everything. And maybe in the process of somebody collating it, he enters probably under age, he puts male. And under gender, he puts Dolapo, for example. You know, if any of us is to analyze it, it's easier for us to spot this kind of thing. Say, no, this shouldn't be in this folder, in this column. It should be actually under name column. So it's easier for you to sort a structured data. And most times when you see structured data, it's usually a flat file. We call it flat files in data analytics. And types of flat files you can have is CSV files. You would have seen CSV files, comma separated files. You can have TSV, that's tab separated. You can also have XLSX, that's like Excel format. You can have TXT, and so on and like that. It's usually structured as what? Rows and columns. It's easier for you to spot any errors in it. So do we get the concept of structured data now? Okay, thank you. So again, we have unstructured data. So unstructured data doesn't exactly follow a specific format. And people that usually see that kind of data is usually those that are into data engineering or software engineering. There's something they call object. There's something called JSON. That's like for JavaScript. The type of, whenever you look at the data, let me just try to draw it up here. It's usually in this kind of format. You see, it's usually like in a script format. You see something like this, name. There'll be like something inside a double column, then comma. You see something else like age. So you can see that it's semi-structured. It's not exactly in a 2D format. It's not like in a format that I can easily see in a table. This is a table. So it's just basically it's just semi-structured. It's kind of organized inside this bucket, inside these braces, but it's not easy to analyze also. Most times you would need analytical programming languages like Python, or maybe if you are savvy with JavaScript, you can still kind of understand what is going on in this space. You can use R2. R is another tool that we use in data analytics, but it's still kind of easier to see. But working with it, you need to have like some specific programming language tools. And then the final one here is unstructured data. Okay, I think I skipped that. And that one is usually what you just find on, for example, on your phone. You can't say you want to see the data on your phone and analyze it. You can't see it as X and Y. It's not a structured data. Or you just see a video, you can only just make insight out of, oh, this video is talking about the current price of oil in Nigeria. You can't exactly say it's in a table format, right? It's still unstructured. Images too, social media posts. So there's something they call data scraping. Most times, maybe when you started working on some projects later, you might decide to start using some programming tools like maybe Python, or start using Python, especially to scrape data from the web, and then organize that data into an Excel format or something, into like a flat file or a structured data format, something that you can organize and then analyze. So unstructured data doesn't follow a specific format. And most times you can have it as text documents. Sorry, someone's calling. Okay. So let's just go on. I'll respond to that call later. So I think we have an idea of what data is now, right? Data is unprocessed information. Every day there's different forms of data flying around you of different formats. Some structured, some semi-structured, and some unstructured. But on a daily basis, when you're walking out, when you're moving out, it's usually unstructured data you find that yourself encountering. So I think the next slide is going to give us maybe a deeper dive into what is going on. Like we have structured data, and then semi-structured data. So as I said here, part of the characteristics of a structured data is that it has predefined data models. Soon, maybe in our next class, we'll go deeper into what a data model is. As I said again, in a structured data, it's easier for you to do what? To do a search. Like, as I said earlier, if we gather all the data of everyone in this class, I don't think we're up to 30. It's easier for me to just give anyone and say, oh, can you get me the name of somebody that is within the age of 30 to 35, for example. It's easier for you to just check, even without using Excel. You can just say, oh, this person is in this bucket. It's easier for you to search. It's usually text-based and shows what is happening. So, as I said again, yes, please. Okay, it's not loud. I'm sorry. Sorry. Okay. Okay, thank you. Okay, sorry, everyone. So as I said again, structured data is easier for you to search. You can have it in an Excel format. If I say, for example, can you tell me the age of Mr. Hillary, for example, based on the data we gathered? It's easy for you to do. So again, most of the formats we usually store it in, where that kind of data usually resides, in a commercial setting, like in a very corporate setting. Let me just call it commercial setting. Is usually stored in a relational database. And we have different types of database. And when you are working with a database, the kind of programming languages you use, what you use basically is SQL. So SQL is what you write. It's called structured query language. And as I usually tell people, whenever you see the syntax of a programming language, for example, you should never be overwhelmed. Because again, all these programming languages are usually in English formats. As long as you can read and write English, it should be very easy for you to code. You shouldn't feel overwhelmed. So as I said, structured data is usually saved in a relational database. And we have different types of databases. But hopefully by the time we start our SQL class fully, be able to maybe just work with one database and then you can start writing code there. And types of relational databases, you have MySQL, you have Oracle, we have PrestoDB, different types of relational databases. But fundamentally, what you just do there is you go there to query data. And when you say you are querying something, what does it mean, please? You're asking questions. Exactly. That's just it. And as a data analyst, that's basically your job description. That's basically what you are doing. You are looking at the data, you are wrangling it, you are squeezing it, trying to get insights from it, trying to get insights that can eventually help in making informed decisions for whatever setting you are in. So, as I said again, structured data is usually in rows and columns. It's the easiest to analyze. The time you might start having issues with structured data is especially in Excel, is when the data records is more than 1 million rows. Excel doesn't have that ability to do more than 1 million rows. So imagine you are working with maybe the data of everyone in Nigeria. We have over 200 million people in Nigeria. How do you want to start querying that data? How do you want to start writing those scripts? That's where databases come in, but soon or later would dive into that. Yeah, so examples of structured data is dates. Whenever I see a date, you know that, oh, this is a date now. We have different formats for dates. You have MMM, YYDD. I believe you get what I'm saying. You have different formats, but once you see it, you know that this is a date, right? Same with your phone numbers, your NIN numbers. Your NIN number is just 10 digits, am I right? BVN2 is something like that. Phone number is usually 11 digits. So most times when you see it, you can't, even if somebody doesn't give you, if somebody gives you a data set, for example, when you see something that has like maybe 35, 35, 49, 67, you might be able to, even if the person doesn't put a column header, like maybe, as I said earlier, like maybe the person didn't put these identifiers, this stuff, yeah. You might still be able to infer, to say, oh, maybe this could mean the age, this could mean the score the person had in an exam, or probably, and if let's say on that name, you are saying stuff like stuff like that. When you just see it, you know that this should be the person's name. Or let's say, for example, you know, let's add another column called phone number. So on that phone number, you are saying stuff like +234. You don't need to think twice before you know that most likely you have 234, blah, 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 blah. When you see this 234, you just know this is the unique identifier for what? For phone numbers. Yeah, if you see +90, I don't know if that's a valid country code, but once you see +90, you probably know that this is probably the phone number of a particular country. Yeah, so you see, that's how structured data is. It's easier for you to trace it. It's easier for you to search, easier for you to analyze and work with it. So unstructured data, as we said, it's usually there's no usually any predefined data model. So subsequently, I think we'll talk briefly about data models, maybe in our next class. So you have an idea of what a model is, what a data model is, before you start writing SQL scripts. Structured data too is kind of difficult to search. Imagine if I go on Twitter now and see all the tweets that somebody was tweeted in Nigeria from 7 a.m. to 12 p.m. If I give you that data, Mr. Hilary, please go analyze that data. How do you really want to analyze it? There's going to be a lot of unstructured to it. You can say, okay, maybe let's even not use that. Let us use that example. Let's say, for example, I've been using a Twitter account since 2015. And I tell you, oh, this is all my tweets. Can you go and search for where I tweeted anything about current fuel price in Nigeria? It will not be so easy for you to check. What you start doing is you start checking each tweet one by one. And some people have as much as 20,000 tweets that they've tweeted since they created the Twitter account up to now. So how do you work with that kind of data? Again, it's not something you can say you want to carry into Excel, put it in Excel and start analyzing. So that's why we have some programming languages that we work with. You can use Python. There's something called natural language processing. So whenever you can actually maybe just build a code that tells you that, oh, anywhere it sees anything about fuel, categorize it as fuel price. So most times it's usually not so intuitive, but it still is. All you just need to do is to just try to be logical when you're working with unstructured data. You have, and other characteristics that I have here is most times it's usually in text format, it's usually in PDF format, could be in images format, videos format. It's not easy for you to say you want to analyze videos sometimes, like to put it in a data in a database or anything to work with. What you eventually use is still like a programming tool, either Python, R, or any other programming language that accommodates that kind of thing. So for semi-structured data, sorry, it is loosely organized. It has a meta level structure. So when you say meta level, it usually has some notations that can actually still point you to whatever it is talking about. So I think maybe I should even talk about one project I did as regards this semi-structured data. So there was a time somebody brought some Excel files, right? No, not Excel, PDF files containing data, lots of data like that. It was maybe the file size of that PDF file was like 230 something gigabytes, different files, but there was like some structure to it. It is PDF, right? But it had some sort of structure to it. Like, there are some PDF files. I don't know what I can use to. Okay, so then okay. Most times when you see some papers, right? Like maybe you want to register your SIM, for example. The paper I'll give Mr. Hilary to register his SIM is the same I'll give to you, the same I'll give to everyone in the class, right? At the end of the day, there's like some structure. Like even though I'm not directly gathering that data into a database or into a table, right? There's still some structure to how the paper will look. So let me just try to visualize so you understand what I'm saying. Let's say this is the paper here. You want to register your SIM, or you go to the bank and you are trying to register for an ATM card or something. Whenever I give you that sheet, when I give you that paper, your name is like this. Name, gender, and stuff like that. Although it's still like in a PDF file or in a sheet, in a document file, it is still something that can still be analyzed, because whenever I'm trying to analyze, I can still see that, oh, in this name part, even if I give it to 100 people, most likely they would always put their names here. There might be little anomalies here and there. Maybe somebody didn't see that it's a name column, a name, it's talking about name. The person might just go and put something else. It's just little anomalies, but generally, there's still going to be some structure to that file. So as I was saying, in that project, we had like different PDF files like this that had people's details like this, some sort of detail of everyone. So the task was to gather every of that structure, gather everything in that PDF file, write a script that would go through all the PDF files, all of them, and then store everything in like a CSV file or a database. That kind of task is like you working with a semi-structured data. It was easier to do because there's one way or the other I can see that in each PDF file, there's a name, there's a gender identifier, there's like maybe country, state, blah, 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 and stuff like that. It's still something you can still analyze. So even if you're writing your script, all you need to do is to just say, tell the script, like I'm just trying to paraphrase or just simplify it. You can tell the script to say, anywhere it sees anything like this, take what follows it, count what follows it, and store it in a CSV file or a TXT file, saying, oh, name, wherever I see name, pick what follows it and put it here. So that was how we were able to work with that file and then gather all of that. So you can see that it was easier to work with because it is kind of a semi-structured data. There's still some little bit of structure. It's still loosely organized, but it's still something you can always work with. Do you get? Okay, so that's on semi-structured data. Our time is really going fast. So sometimes whenever you work with that kind of data, you can still kind of store it in a database. And maybe for the databases you store that kind of data in might not be the conventional databases like SQL, MySQL, PrestoDB, or stuff like that. You might be using other types of databases like there's one they call MongoDB. It's usually used by all these guys that work with backend, do backend engineering, like build websites. So there's a way they can script that kind of data and keep it in like a database. So examples, as I said again, some of the examples are like server logs. Most times, I don't know if maybe you've gone deep into your phone's storage before. Like maybe sometimes you have lots of files on your phone and your phone is saying you should delete some things. Maybe when you're checking, you start seeing some funny files. So those kind of files are like logs based on your phone, what you are doing on your phone. To just go there, to just store some files, it's just store some files there and then log it there. So that's how a log looks like. So I think enough of this. Let's go further. So again, yeah. So I think this slide kind of gives us an idea of what the kind of format the three types of data usually come in. Sorry about the way the thing is looking, but basically, unstructured data is like in a text. The university has 5,600 students. John's ID is number 1. He is 18 years old and he already holds a BSc degree. If you see this kind of thing, it is kind of boring. It's going to bore you out quickly. You are looking at, why are you boring me with these details? Look at this unstructured data and look at this structured data. Which one is properly organized? Which one is neatly organized? Structured. It's easier for you to just say, oh, you don't need to bore me with all of this story. Why are you telling me all this story? What is the age of David? David is 31. I don't have to start reading the university has 5,600 students. John's ID is blah, blah, blah. So imagine all of this unstructured data sentence here. Let me just try to use the board there. Imagine all of this that we have here. Can we see, please? Imagine all of this that we have here. Look at how it was just structured. When it was structured data, look at how structured it was. Imagine if you have look at the first statement there. The university has 5,600 students. Imagine writing everything about the 5,600 students like this. How would it be? To be tedious, it would be tiring. But it's easier for me to just go, like maybe somebody says, okay, Mr. Hillary's ID number is 5,000, maybe 5,001. It's easier for me to just go on my structured data, start searching, or just do like a random search, scroll down to where 5,001 is, and what would I see? I'll see his name, his age, and then the degree he has. Unlike for unstructured data, I'll start scrolling. At the end of the day, to be tedious and to be tiring. So for semi-structured data, I told you it's usually like in this is HTML. I think this is an HTML script. One way or the other, you can still kind of see what each column is talking about. For example, when you look at this age tag here, you can say that, oh, any number between that age tag is definitely the person's age. It's still easier to analyze it compared to unstructured data. I'm looking for Mr. Hillary's age, and they said it's 5,000. What if we have like 20 million students that I'm working with? By the time I'm done scrolling, I'll just be tired and I'll just go and sleep. But for structured data, even this structured data self, imagine, okay, maybe when we will dive deeper into that. For structured data, it might still be a bit tedious. I still told you Excel doesn't take more than 1 million rows. And Mr. Hillary is maybe the 10 millionth student, in quotes. How do I want to do that? That's where SQL comes in. You can just write a simple statement to say, select name, age, and then degree. So let me just try to write that script somewhere here. Okay, we've done one of this. So this is, what I said earlier. Just imagine what we have in that structured data to be your to be in Excel format. We are now trying to get, okay, as I said again, let's say we have this database or this table on a database, and we are trying to get maybe Mrs. Dolapo's age, and somebody already told us that she is the 10 millionth student in that class. For Excel, since I can't see this in Excel easily, I can use SQL. There's some, as I said again, SQL is structured query language. Structured, emphasis on structured, is usually in a structured format. Query, what are you querying? You are trying to ask questions. So what you do, there's a basic syntax you can use for it, and that is, in SQL, select statement is always important. So what you are doing is select what? So I think we will do like a little quiz on this later, Sha. So select, this is the age, this is the name, right? This is the age, and then this is what? The final one should be, let's call it degree. Okay, somebody, maybe I walk up to you and say, oh, please, can somebody tell me the degree that Mrs. Dolapo has? I'm not really concerned about the age. I want to know the degree she has. What I'll use is a simple select statement saying, select what? Name. Please don't be overwhelmed. This SQL, as I said, any of this programming language is simply English. Just have it fundamentally in your mind that it is simply English. It's just the syntax, the way you order it, that matters. So what am I saying? I'm saying we're trying to know Mrs. Dolapo's age. So select name and degree from, so this is the syntax of SQL. From, somebody should give me a name we can give this table. Give me a random name. Student data, okay. So let's call it student. Please don't mind my handwriting. Student data. So most times, whenever you're naming tables in SQL, whenever the sentence is like a bit long, maybe it's like a conglomeration of 2 or 3 words, you always use this hyphen, underscore to name it. Even when you're querying your data, it's always advisable you use underscore. You can't use hyphen. So let's call this table, as you said, student data. So we are trying to select what? The name and then the degree from, what's the name of our table? Student data. Student data. The next syntax is what? Where. Where what? Someone should try to help me. I'm trying to know Mrs. Dolapo's degree. So this is what I will use. Please don't be overwhelmed, even if you don't understand the concept now. We'll still go deeper into it. So select name, select degree from what? Student data, that's the table. Where the name is equals to what? What's her name? Dolapo. Thank you. So if I do this search on a database, for example, it's going to return a data here, telling me the name and degree. So those are the 2 columns I asked for. I might want to include age. Do you understand this concept? Is it making sense to you? Okay, so and now I have a question. What if we have 5 or 10 Dolapos in the class? What is going to happen? And out of, okay. Exactly. So that's one insight. Yeah, I like that. So it's, again, let's say you're, yeah? Exactly. So that is going to make, when you are doing that, you are trying to drill down on your analytics, you are trying on your analysis. So if you are saying, okay, give me Dolapo, what if on this table we have like 10,000 Dolapos? How do we work with that? It's going to still, what it's going to return is still going to be a lot of Dolapo, a very big data, maybe a data sheet telling us different Dolapos. One way you can drill down, as you rightly said, is what? Surname. So let's say, what's your surname, please? Do you mind? Wale Kende. Okay, that's a very unique name. But imagine somebody is using a surname like maybe Lawal. Lawal is a very common name. Or a very Ojo, all those kind of common names. It's going to be very difficult to. So that's why most times it's usually good for you to have lots of lots of insights, or let's say data that I can use to drill down. Let's say they now say, okay, this Dolapo person. The person is staying in Ebute Metta. It might be easier for you to drill down and then, but again, you can have lots of Dolapo staying in Dolapo. It's staying in Ebute Metta. What if we say Dolapo staying in Sokoto? It might be easier to still, so you can see how it works. You just keep asking yourself questions. That's basically what data analytics is. Keep asking yourself questions. Still keep asking yourself questions. Keep querying the data. Keep asking with your scripts. Keep asking till you find what you're looking for. So, done with that. Let's go on. So, fundamental concepts of data. Yeah. Oh, we've spent over 45 minutes. Interesting. So, as I said, data is the foundation upon which businesses, organizations, and technologies build insights, improve processes, and make decisions. So, let's try to use this table that we just worked with here right now. Let's try to use it to paint a scenario. For example, let's say you're working in a bank, and somebody says, "Oh, we are trying to reward." Or let's say it is a school student data. We are trying to reward a Dolapo that had a very high GPA in school. Like maybe she has a GPA of 4.5, GPA 4.5 above. We are trying to offer the person a scholarship of 10,000, and it's only for one Dolapo. Or let's use a bank. I think a bank would be a best fit, so we'd understand the consequences, in quotes. You are in, you work with a bank, and they say they want to reward a student that the person's name is Dolapo and the age is maybe 45 or so, and the gender is female, and they just piece things up like that and give it to you and say, let us reward this person. We have this person in our database. Look for this person and reward this person with 10,000, maybe 10,000 US dollars, for example. And I am in the analytics team. I didn't even ask further questions. I just went, pa. I wrote one SQL script. It gave me like $5. And out of that $5, I was like, any mini manimo. Let me pick number 4. I go and give my Oga. Say, Oga, this is the person you should reward. Is it something that is, what do you think of that kind of process? Eh? Please, I want to hear feedback. Eh? Eh? You didn't go, you didn't query deep. That's one insight from there. You didn't go deep. You just did guesswork. Sir?
If the 4 had the 4.5,
Mm-hmm.
I think they might now still
Look for another.
Saying this one had 4.8.
Mm-hmm. Or the person should be staying in Sokoto, for example. Let's use a state. So you see that when you keep when you keep deep diving, keep drilling down, you keep finding more insights, more ways to actually streamline to say, oh, this is the person we're actually looking for. You see, so imagine I just go and give the name to my organ, and then they credit that person 10,000 US dollars. And the person is number one, not in Nigeria again. The person is not a student again. The person has gone and put base on his neck now. So you can see if you are not doing deep dive in your data, you just keep saying that, you just keep making wrong decisions. And okay, there was a time we worked on one data back, like when I was still starting out. There was this bank that used to claim, oh, we have 5 million customers. When you hear 5 million customers, you start feeling, these people, they are top guys. So let's just try to paint it together, and then it will probably just let you understand how data analytics really works, right? And so let's call this bank Power Bank. Mm-hmm. This bank is claiming they have 5 million customers. A random person will be like, this bank, and they should be seeing a lot of money. They have 5 million customers. Wow, interesting. But out of that 5 million customers, they now give you that database. You now check. You now see that out of that 5 million customers, it's just maybe 1,000 customers that have above 5 million in their accounts. Start like, 5 million, there's only 1,000 that has above 5 million. You check again. You say out of this 5 million, on a daily basis, you have just maybe 300 1,000 people that perform transactions daily. You start, if you are on the board of that kind of bank, you start calling, I say these people, they don't really know what is going on in their company. You check again, you check these 5 million customers, you see that their total active customers for the past 3 months is not even up to 1 million. And somebody might just come and start bogoing you with, these people, this bank, they have 5 million customers, they have 5 million customers. When you are doing a deeper dive, you are just actually saying that at the end of the day, there's no, like, there are lots of discrepancies. It's not, it just keeps. So I believe you get the idea of what I'm saying. So that's how data is. It's to just put this inquisitiveness in you, for lack of better words, to keep asking questions, to keep querying, keep checking. And it doesn't really matter even if you are into agriculture, HR, accounting, or even a a fuel, what they call it again, oil and gas, if you're into oil and gas. As long as you deal with data on a daily basis, data is always coming in. You have to just keep asking questions and look for how to improve processes and help the management make better decisions. You might, maybe we would give these examples later, but let's just go on. So as I said, data is the new oil. People have been saying this since 2020. On a daily basis, you see how data can be very important. On a daily basis, you might not know how important data is until when you check and you go and squeeze the data to ask questions. That's when you know what is really going on. So, as I said again, data is a vital asset for organizations and it helps them in enabling, it helps to enable informed decision making based on objective evidence rather than intuition. The other time when I gave an example of having $5 pause, I was trying to use intuition instead of using objective evidence, like querying the data to know the exact dollar pause we are looking for. Instead of using intuition, like, okay, let me just keep guessing. Maybe it's this dollar pause. I like this person's surname. Maybe it's this dollar pause. You can't be using intuition when it comes to data. So, as I said again, by leveraging data, organizations can accurately assess situations, identify opportunities, and mitigate risks to achieve their strategic goals. Yeah, so as I said here, like oil, data is valuable, but if unrefined, it cannot really be used. I'm sure you understand what I'm saying, sir. You really work in the oil and gas sector. If I give you crude oil, and I say, okay, take this, I gave you maybe 50 kilograms, 50, what do you call it, 50 kg, 1 full kg of crude oil, take. Go and use it. Go and use it in your generator. It will look like as if I don't like you, right? It's because the fuel is what? In its crude format. That's how data is. Data is usually in its crude format. You need to refine it, refine it deeply before you can actually make meaning out of it. So we spent a lot of time talking about the basics. So it's our topic of the day. We have data analytics, data science, and data engineering. So these three, they are like this. They are together in this whole data ecosystem. Especially in Nigeria, I think what we have mostly in Nigeria is when you look at the roles, you have this analytics, you have HR analytics, you have people analytics, you have different financial analytics, they're just trying to infuse data analytics with whatever standing role it is before. You see that people actually know where the world is actually going now. So most times you start seeing people using Excel, HR professionals using Excel, people into accounting using Excel, even in agriculture itself. You start hearing of agricultural analytics, if that's a word, but it's something that's actually feasible. You just keep seeing people trying to infuse analytics into whatever they are doing on a daily basis, instead of having a standalone data team. People are already infusing it with traditional roles, like don't even call traditional roles, other roles like that are standalone in corporate organizations. So let's go on. So as I said here, data analytics, data science, and data engineering are crucial components of the data ecosystem. And data analytics derives insights for business decisions. That's your basic role as a data analyst. You are just trying to help your company or the business you're working with to make better business decisions. Data science it does more of prediction. Let me predict what's going to happen. That's what, so it's like a data scientist is like usually like a prophet in quotes for corporate organizations. And data engineer is one that builds the infrastructure to store and process data. And in essence, what a data engineer is basically doing is to just enable the analyst or scientist or whosoever is in need of that data to have access to that data in real time. So that's just the basic work of a data engineer. So any questions so far? Am I moving too fast? Are you understanding these concepts? Or is it too technical? Please let me know so we'll go. Fine, fantastic. Yeah, thank you so much. Okay, so, so for data analytics, we are still going to do like a deeper dive on all of this. I think from my slide, I started with data analytics, then data engineering, then data science last. Hopefully today, I wish we could just even start our SQL class. So we just, at least from this basic example I have here, we can actually just start somewhere and then start. So what is data analytics? So data analytics is basically the process of examining, cleaning, and interpreting data to extract meaningful insights that aid in decision making. Whatever you are doing as a data analyst, as I said, let it just keep ringing in your ear. You are trying to first get insights into what is going on in your data, and inform by the action of that, you are now helping the company, the individual, or whosoever, whatever it is, to make better decisions. Decision making is like at the tail end of what you are doing as a data analyst. You're trying to make better decisions. You might have like a large data, and then maybe your company, they say your company is raking in maybe $1 million on a monthly basis. You don't know how much is coming from this region, that region. You don't even know if some regions are even causing losses for you. You can see how that dynamics works. It's not so as I said again, data analytics is the process of examining, cleaning, and interpreting data to extract meaningful insights that aid in decision making. So, as I said again, it is the process of transforming raw data. Data is usually in its raw format. And what do we call raw data again? Call raw data unprocessed information. It's just that data is just sitting there in your database or in your Excel file. It's just sitting there. You don't know what is really happening. So you need to go and check. So as I said again, it's the process of transforming that raw data into meaningful information. Like the example we gave earlier of those 5,600 students. That's raw data. It's just too raw, so noisy, so tedious to process. You are now trying to gather all of that, put it in a what? Arrange it in a way that to make sense, to be meaningful. That way you can know, if you had that kind of, let's say as we had that unstructured data in that format, we had 5,600 sentences like that. If you want to try to count how many male people are in that sector, it will be difficult to count. Do you want to start counting MAN? Man, 1, MAN, 2. If it's in a structured format, it is easier to read. It's easier to make sense. And then maybe, for example, you are in a school that they say, oh, out of our 5,600 students, we are trying to do like a gender balance. We want to have an equal number of the male gender and the female gender in the school. If it's in that structured data format, you might not be able to really make sense of it. But if it's in that structured data, you can just drill down and say, oh, how many male students we have here? We have 2,600. That means we have more female students. Let's try to bring this number up. Anybody we are trying to bring into this school for the next 2 or 3 years should be female or male based on the decision the management is making. So that's basically how it works. So essentially, we have 5 types of data analytics. 5. There are 5 in number. We have descriptive analytics. That is like, okay, let me just clean this. And Okay, let me just write it out so we'd understand. You have descriptive. When you hear descriptive, okay, Maxwell is not there. I wanted to ask Maxwell a question. It is well. Okay, yeah, it's fine. It is well. What does, if they say, if I talk about descriptive analytics, what do you think it's doing? You can read, you can actually read and then try to make sense of what's there. Exactly. And to describe what is actually happening rather, what has happened in the past that brought us to this state. Do you get? So that's what the descriptive analytics is talking about. It's talking about what happened. Okay, we noticed that our revenue, the money we made from Alagomeji, for example, last year was 10 million naira. Now we are saying that it is 5 million naira. What happened? What do you now do? Go and check historical data from beginning of the year down to this point. What happened? Was there a time that there was like protest? Was there a time that there was issues? Maybe we had network issues and stuff like that. That's what descriptive analytics is about. Describing what happened. Do you understand? So as I said again, this type summarizes historical data to provide insights into what past events and trends. So it's usually like you going back to historical data, all the data you've gathered for a while, check it to see how did we find ourselves in this point? Last year, Naira was 467. Now we've had maybe times 4 of that now is like 1,600 or something. That is descriptive analytics. You are trying to find out what really happened. What happened? What brought us to this point? So the next is diagnostic analytics. And that one is answering, okay, let me just put it like so. To just summarize, descriptive analytics is what? What happened? That's the question it is asking. Describe what happened. Number 2 is what? Diagnostic. And diagnostic is what? Why did it happen? Kilo shele gongon. Now, in other words, diagnostic. And as I said, this type investigates the reasons behind trends and anomalies in the data to uncover underlying causes. As I gave in the example earlier, right, that in Alagomeji used to be our cash cow, where we used to get lots of money from. We used to get $10 million, lots of money from Alagomeji. And this year we are seeing 5 million. What happened? They call you, manager of this region. What happened in this place? You've checked, you've asked, what happened? Oh, what happened? They've told you what happened. Why did it happen? What do? Start checking around. Was it that they burnt our fuel station? Was it that they did this? What did they do at that point that brought down our sales or brought down our revenue? Thank you for that word. What brought down our revenue? Is it that there were like some protests? Is it that people are disturbing us in that area? Or did somebody run away with our money? So you just keep asking, why did it happen? So you can see that data analytics, whatever you're doing data analytics, you just keep asking questions. You don't take intuitive answers as answers. Somebody might come and tell you now, the sky is blue. Before you say, the sky is blue, you have to go and check. Check very well, check before. So you don't just take intuitive answers as answers. You have to always ask questions. So that's what diagnostic analytics talks about. So the next is what? Predictive. Okay. Okay. So predictive analytics is what? If they say something is predictive. My music brother, Chief, Favor, right? Okay, so can you read what predictive analytics is about, please? Please try to be audible.
Statistical machine learning past future outcomes based on historical data patterns.
So this kind of predictive analytics is what you usually find a data scientist doing, or somebody that is like a data analyst that has solid grasp, some kind of grasp of machine learning or maybe statistical models to predict what will happen. So I can give you like an instance of one project I worked on at a point in time in one company I was working before. So what we did in that place was it's like an e-commerce company, like an e-commerce. You know what e-commerce is now? All those it's just like Amazon in quotes, Konga, Jumia, and stuff like that. So we built like a dashboard to predict how much the company is going to be making on a daily basis. And to some extent, it was like 90 to 95% accurate. Most times when you check the discrepancies, it's just going to be like maybe 5 million short or 5 million above. You know, that kind of lets the management know, oh, this is actually working. But that's like predictive analytics. It's not enough to just predict. It's just like me coming to tell you that, Mr. Larry, yesterday you made 200,000. Tomorrow you are going to make 250,000. And you make that money. I think that is not even going to be so sufficient for you. You would want to find out to know that, oh, what is it that was selling? What was the thing that was selling the most? That is bringing more money. You can see how, so the management, before I left, the management now tasked us, oh, okay, now you said you are going to make, this is the amount you are going to make. We made the money. What, can we know can you build like a model, or can you do like a predictive analytics to let us know what you think we should sell that would make us even earn more than this? You can say, oh, if I'm telling you going to make 250K, there's nothing special in it, right? Like you're going to make 250K, and make it, these guys, I think it's a profit. It's not so sufficient enough. What can I sell that will bring more money to me? If you like predict, if you like don't predict, I'll still make the money, right? What would make sense is for you to tell me, what should I sell that would bring in, so you get the idea now. So that's just basically what predictive analytics is. Predict, and it's not that you just predict and say, okay, Mr. Larry, you're going to get to 50K. Either you predict or not, I'm still going to get the money. How can I make more than that? What should I do that will make, what is the product I'm actually selling that's bringing this amount of cash on a normal day? Do you get? So that's how predictive analytics works. And we have prescriptive. So prescriptive should actually even come before predictive, I think, in this whole thing. So prescriptive, I don't know. My work, please, can you read it? Chief, welcome. Okay, can you read the question it is answering?
What should we do?
Thank you. So go on.
This type recommend action based on data insights to optimize decision making and achieve desired outcome.
Thank you. So we can see that. So let's still use our Alagomeji example. What is this prescriptive telling us? This is what you should do if you don't want to see 5 million naira next year. We noticed that number one, we requested for new laptops. You did not answer us. So this is what we say you should do, so we would make more money or even go above our KPIs, go above the amount of money we are making. So that's what prescriptive is basically telling you. This is what I think you should do. I'm not trying to force the decision on you, but this is the insight I came up with. Oga, this is the insight. Whatever you've seen here, what do you think? This is what I think you should do. And so that's basically how prescriptive analytics works. So here we are spending a lot of time on these basics, but it's always good to just start with the basics. So to really help us. So the data analytics life cycle, right? When they say life cycle, that's end to end. This is the beginning stage, and this is the end stage. So there are like 4 key phases. So there are sometimes it might be more than that, but essentially in basic form, they're usually in four phases. The first is the data collection stage. And yeah, there are different ways you can collect your data. You can collect your data from by simply sending like simple forms that I send to people. Ebuka, this is a Google form. I want you to share to people around staying in this Alagomeji area to gather their name, their age, their marital status, their revenue, blah, 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 gather everything. That's simple data collection. For any simple data analytics project you're actually starting in. So data collection is at the first. The next is data cleaning. Data cleaning is the next stage. For example, maybe when Ebuka was gathering the data, Ebuka went to put age in name and name in age. You can't start using that kind of data to start, you cannot be analyzing that kind of data. It's not going to be helpful. You don't know what I want to use the data for. So you have to clean the data, ensure that the data is in its right format for analysis. So you give me the data now, and as I'm going through, I am saying that, I'm seeing lots of Todimu. Todimu like 4 times. Todimu filled the forms like 4 times. Or Emmanuel filled the form 4 times. And this, you didn't know the reason why I'm telling you to bring the data. Maybe the reason why I'm telling you to bring data is because we are trying to reward people in the community. And I'm trying to reward Todimu. Todimu is seeing like 4 different alerts. Pa, pa, pa. That's Wahala now. So it's very important that you always clean your data. The data should be in a properly structured format. No duplicates, no missing values, no null values. It shouldn't be that, after you've gathered all the data, and as I said, it's a reward, so because we are trying to reward customers. That's why I said you should gather data. And under account number, Todimo has been a very consistent customer with us for a long time. Another account number, we can't find Todimo's account number. See, it's not going to be so nice. So it's very important that you get the data collection stage and data cleaning stage is like one of the most important parts. You must ensure that the data is clean. There's no duplicate values, as I said. So Todimo will not go and see like 4 different alerts and it will cause Wahala, and they will deduct it for your salary. You see how important it is. So after the data cleaning, the next stage is data analysis. That's where you analyze the data, start checking in the old data sets that Ebuka collected. How many male people are there? How many people are collecting above 50K? How many people are making below 50K? You just keep checking and then start asking questions before you now do the data reporting. Data reporting is usually at the end of the life cycle. And that is in your report that usually have stuff like your insights. The insights, you have the insights there, and then the decisions, like the kind of decisions you would recommend to management. You can just recommend the recommendation. Out of these 50 people that we gather data from, 25 are underemployed. This is that. So that way, you can't just carry an Excel sheet to go and give the management. Okay, this is the data. Do you want your guy to start checking by one and stuff? You have to make it presentable, visuals. Visualization is very important. That's also like a very important phase in the data analytics lifecycle. So as a point of, let us just try to, can somebody just read the 4 again for us? What are the 4 essential stages? So data analysis is different from data analytics. I was expecting somebody to ask me that question. So data analysis is the process of you trying to check your data, wrangle the data, ask questions. You are just writing scripts to just know what's really going on. But data analytics is the all 4: data collection, data cleaning, data analysis, and data reporting. So as I said, data analytics is different from, not really different, but analysis is the stage where you are checking your data, you are trying to know what is really going on in your data. That's analysis. But analytics is the all 4 stages, the whole processes, the whole phases happening in what? In the data analytics life cycle. So analytics is different from analysis. Analysis is when you're already working with your data. You're already checking how many male people, how many female, what's their age gap, are they Gen Zs, are they millennials? That's the analysis stage. So let's go on. See, time is really racing fast. It's racing very fast. So, so data analysis and visualization. So as I said, visualization is the graphical representation of data.
You can't say, as I said earlier, imagine you have a database that data of maybe everyone in Nigeria is sitting, like all the data of everybody in Nigeria. We have over 200 million people. I'm sure we have over 200 million people in Nigeria. If you have to go and present that kind of data, if they tell you to do, okay, maybe do like a age analysis of people in Nigeria, yeah, would you just carry that database and go and meet the stakeholder to say, oh, this is what we have in the database. Go and be checking one by one to know the amount of male, female, and those gender or demographic distributions. You have to present it in a visual format, in a way that once I just look at it, I know that this is what I'm saying. So for example, if it's male, obviously we have just two genders, right? Male and female. Let's say this is, you use a pie chart to represent it. Let's say this is, let's call this 75% and then 25%. This is just, I'm just coming up with random facts, right? Let's say we have 75,000. Let's use Alagomeji as an example. We have 75,000 people staying in Alagomeji that are male. And then we have 25,000 people staying in Alagomeji that are female. It's easier for me to take this data and present it to the stakeholder that, oh, this is what is actually going on. We have 75,000 people in this our region that are male, and then 25,000 people that are female. It's better for me to present this kind of data than to just carry one Excel sheet that is saying Jide, male, Hilary, male, Todimu, male. It's going to be clustered. It's not summarized. You get? It's not summarized. And it's always very important that whatever you are reporting is summarized, properly summarized. And when I just look at it at a single glance, I know what is happening. You don't need to start taking me to the database to say, oh, this is what is happening. Just give me a visual. That's why I said it, like at the end of the life cycle, data reporting or visualization. So we have different types of visualizations. I'm sure in the subsequent classes when we are doing visualizations, as Mr. David said, you'd understand better what's going on. So I'm going to skip this. So yeah, these are the different types of charts you might have in your reports. You have bar charts, you have line graph, you have bar. This is also bar charts, but in an horizontal format. This is like a 3D shape. Different types of charts. You have the pie chart, you have the donut chart, you have the Venn diagram, you have the pyramid chart, and stuff like that. So let's just go into data engineering. So for data engineering, well, before we go on, is there like any questions so far? Are you finding the class insightful? Do you have any question? Okay, please. Good afternoon, Chief.
Yeah? Okay, I want to know what's the difference between data analytics and project management, because I'm seeing something kind of similar.
Okay.
Because data analytics here is encompassing so many responsibilities assigned to maybe a particular work, or let's say like a project.
Okay.
So I'm seeing some kind of similarities.
Okay, data analytics, as you rightly said, is what you're working with is just strictly data. That's why data analytics. But like I said earlier, as I was telling people earlier today, that under data analytics, right, you have what people are trying to do these days is they are trying to bring in like do like a fusion of data analytics with whatever role you are doing. Like our brother here is a pharmacist now. Tomorrow we might see something called pharmacy analytics. I don't know if yeah, so something like that. So you see, like they're just trying to bring. So it's just a way of just bringing data into whatever you're doing. Because everywhere you are, whatever you are doing, even as an individual, you're always working with data. As I said earlier too, let's say we finished this class, you checked your map, you are going to Ikorodu. Somebody tells you to take you 25 minutes to follow Third Mainland Bridge, to take you 3 hours to follow Ikorodu Road. Well, as an human being, as you've processed all of that information, what are you going to do? You're going to make an after you do an analysis, you're not going to make an informed decision because you know what is going to happen. If I don't follow this place, I will spend 3 hours of my valuable time here. So that's just what data analysis is. We are working strictly with data. But project management, I think, is there anyone here that might want to help us with that before I try? Okay, yes.
Overseeing every area of the project, ranging from analytics to the people doing, if, for example, you're doing a building project, you handling the project, you are supposed to check in with the contractor, the medicine man, the welder, everything. You are the overseer of that project. Yes, the overall seer of that project. But for a data analyst or analytics, it's just strictly on the data of that particular project.
Thank you very much. Does any other person have any? Okay, Ebuka. Okay.
You said something about in the data analysis lifecycle, data cleaning. In the process, when you see like missing data, how do you deal with missing or incomplete data?
So for missing or incomplete data, if it's something you can neglect, like a negligible point of data, you can ignore. If it's something you can capture again, try to capture it again. Do you get? Or I'm trying to think of a proper use case where if the data is missing, it might be problematic. So it's either you capture the data again, or also there are some statistical models too, like some under data science, there's some statistical models that can actually use to predict what this missing value should be. Do you get? For example, let's say, as we said in this random class, and let's say our age range rather, is from 10 to probably 49. We've filled in the data randomly. There are some statistical models that I can actually use to just predict, to say, okay, based on this data I have here, what do I think what do I think Jide's age should be? So there are either 3 ways. Either you neglect, or most times it's not good to neglect. 2, use statistical models to predict. So that's as I said again, that's like the core thing data scientists do. They do a lot of prediction, do a lot of predictive analytics, predict. What would the company make? What will happen here? What will happen there? So there are some statistical models I can actually use to fill in missing data. Yes.
Under data analytics, you said it has 4 types. That's a descriptive, diagnostic, predictive, and prescriptive, right?
Yeah.
So at any point in time when you are analyzing data, can you stick on a particular format and say, okay, fine, or maybe just like, for example, like in economics, let me say, you have different school of thought. There's when someone actually expresses his own thought and idea, you know that this person
is using this,
is a Keynesian, or this person is a monetarist.
Okay,
so are they like maybe data analysts?
Okay, you must use this format.
Yes. Or
it's not really.
Do you have to use particular format at every point in time, or you could maybe?
No, so you shouldn't really bother yourself about that. It's not really cast in stone that you must do descriptive. I can just come up, let's say your boss at work can just call you and say, sorry, what's the name? Daniel, please, can you just help me know? Can you let me know how much we're actually making in Lagos region? Like maybe from the sales of, let's say you're selling mobile phones. That is descriptive. You don't really need to start thinking, oh, this analytics I want to do now is descriptive. It's not really cast in stone. Your work is to just dip your hand into the data, try to just bring out insights, and then what you think your boss really need. Maybe at the end of the day, you now take to your boss, and your boss says, oh, okay, yes, this is, I like how you've worked on this. The next question he asks, I'm sure you saw the questions we put there. Okay, we are now saying that, okay, after you've done all the sales, we are saying that at the end of the day, we are seeing maybe less sales for some phone, maybe like for Samsung phones. He now asks you, why did it happen that we are not seeing much sales from this thing? What you are now doing is diagnostic. So it's not really cast in stone. You don't really need to put your mind to say, oh, this is what I'm doing, this type of analytics I'm doing. Your work is just I'm just trying to try to put them in different buckets. So you just know that, oh, whenever you're doing this kind of thing, this is what it means. But it's not like it's really cast in stone to say, I'm actually doing this analysis I want to do is descriptive, is diagnostic or prescriptive or whatever. So it's just basically, just put your hand in data, whatever question they ask, then just present. So I hope that answers your question. Thank you. So any other question, please? Sir, do you have a question, please? Okay. Do you have any question? Okay, so let's quickly touch data engineering. So it's just in recent times that this data engineering has actually been becoming more popular in the whole data ecosystem in Nigeria, not in outside the country. Or their job is very important. So let's just touch this briefly as we go forward. So data engineering is the practice of designing, building, and managing the infrastructure and systems that enable the collection, storage, and processing of data. That's a lot of long English. Well, let me just try to paint this scenario in our mind. When you look at the weather app on your phone, do you ever think of how this, okay, no, don't let us even use, okay, let's try to use maps. Let's say your maps, for example. How do you think in real time, you can actually see the location where you are and the traffic condition of that location? That's the work of the data engineer. The data engineer is the person that it just makes the data ready. It's like in real time, whatever you are doing in real time, you can see what is happening. A data engineer's work is to just prepare the data, ensure let me just put it like this. The work of the data engineer is definitely, usually the data is usually in different formats. Is in maybe, okay, let me use this specific use case so we'd understand, so I don't skip some important things. So let's use maybe, I'm thinking of something I can use that would be easy. That would be something that is relatable rather. Let's use, okay, how many people use child deck here? Just going to use that as an example, so as a use case, so you understand what's going on. So child deck, let's say this is child deck, right? This is your phone, you're hungry, you go to child deck, and you go to maybe under the place restaurant. You know child deck now. You go and select the food you want to eat. Bam, as you select it, almost immediately, child deck will tell you the amount of time it will take before your food gets to you. You get? So basically, so maybe child deck don't really have data engineers, but what I'm trying to say is the data engineers, what they're really doing is they are the ones gathering the data from different places, from your Facebook page, from whatever page it is. They now try to unify everything, ingest it into a database that the data analyst and the data scientists can now pick from. They're the ones that basically what they're doing is they're the one preparing the data. They're the one preparing the data to ensure that it is in a clean, clear, consistent format, and then it is secure. Do you get that? I would have used, I don't know how to bring data engineer into the whole of this, but maybe for Uber, it would have made more sense if I used Uber. Okay, so for Uber, right? Almost in real time, when you just clicking, you go on your phone, on your mobile phone, and you say you want to request a ride. Where you are going to, I'm going to Jibo. As a search, almost immediately it tells you the amount of time it will take before your driver gets it. In real time, there's like a pipeline going on behind the scenes that has been built. So a pipeline is like a series of phases. I will explain that later, but let's just imagine what a pipeline is. So basically, as you just click on request ride, that data is immediately sent to Uber's server or whatever it is, whatever architecture they have here, whatever infrastructure is here. As you just request your ride, almost in real time, it is contacting Uber's server or whatever it is that is there. And then they tell you the time that your rider will be here and the amount is going to charge. Imagine if you have to select the ride and it's taking you analyze. So it's like they are the ones just ensuring that the data is readily available for the data scientist, data analyst, and also the third party. You are the third party. As I'm clicking on this thing, I don't want it to be that I'll be waiting too long before I get the ride. Although there may be external factors, like maybe if the rider is busy, that one is like external factors. But internal factors, they try to ensure that immediately you are clicking on that link, they just try to start looking for the closest rider that would come to you that can. So you see how important a data engineer is. So let's just go on. I want somebody to help us with that data engineer volunteer. Please.
Logarithm. Does logarithm works here? Let's say based on the way I use my maybe device, I use my
True, yeah, so we're coming to that, yes. So it's algorithms you meant to say. So maybe it's a good time to talk about it. How many of you have used maybe Netflix, YouTube? So most times you notice that because last week I listened to a song by Nathaniel Bassey. So as I go to YouTube again, the next thing they are doing is my first page is Nathaniel Bassey's song I'm seeing. So there's something they call recommendation systems. So that recommendation system, what it's basically doing is based on your past activities on this website, your historical data here, this is what you came to do when you came here. This is what we suggest you when you come again. You'd have seen this kind of thing, Seth, in maybe when you go to a website and say, accept cookies. Normally, whenever I see accept cookies, I think they want to give you biscuits, but it's not biscuits. So what they are just doing is they're trying to see everything you do on that website. Maybe as you're on YouTube, you searched this song, or you're on Netflix, you watched an action movie last week. The next time you're coming there, there's a recommendation system that will just recommend the kind of movie you should watch or whatsoever. So that's like, as I said again, it's still their work too. So what they are just doing is based on what you've been watching over time, based on what you've been doing over time. Anytime you come to our website, this is what you always do. When next you come again, this is what we give you. This thing has even been happening on Instagram in more recent times. I used to think I was thinking too much before. That maybe I'm talking to someone now and I'm like, I want to buy a new shoe. As I press send, I go to Instagram. The first thing I see is a new shoe, a page of a new shoe. I scroll 2 or 3 times. I see another thing. So that thing is called social listening. So there's like a recommendation system. I know if you look at this thing holistically, you know, Meta is the owner of WhatsApp, Meta of Facebook. They're the owners of WhatsApp, Instagram, blah, blah, blah. So do you not know that your data is like intertwined in everything? They would have just seen you talking about maybe new shoes on Instagram or something, or maybe you did a random search on Instagram to say new shoes. Before you know, anywhere you go, it's as if they're always following you. Why? So that's just it. Again, that's just part of the work of a data engineer. But most times their work is usually automated. Imagine the amount of people that are actually trying to request for a ride now on Uber. It's a lot of people. They expect someone to be managing that data and later, and let me gather. So there's something they call pipeline automation. It is automated already. Just keeps logging the data somewhere. Because again, somebody that's gathering data, his work should be prone to error, right? So most times what they do is they try to make that thing automated, that flow, that pipeline automated. So does that answer your question? So again, what you meant to say was algorithms, right? Okay, thank you very much. Yeah. So let's just briefly touch this. I have less than 25 minutes. I think we'll touch SQL today, but let's go on. So data engineers focus on building and maintaining the data architecture and pipelines, while data analysts and data scientists concentrate on doing what? Analyzing the data and deriving insights. So for a data analyst, you are not the one going out to start gathering the data from different sources, like from web analytics, from the website, you're trying to gather the data. You go to Facebook, try to gather the data, go to Twitter, gather the data, go to different places, go to maybe where they show the sales of the company, gather the data. It's not something that the data analyst or data scientist should be doing. It's basically the work of a data engineer. The work of data engineer is to just gather the data from different sources, aggregate it together, ingest into the database for the data analyst and the data scientist to work with it. So does that bring some insights? Yeah. So the responsibilities of a data engineer is, one, to build the pipelines. Like I said, doing a lot of that work is not something that should be easy. Most times what they do is they create like a automated process, like a workflow that is just automated. When you are trying to gather data of everyone in Alagumeji in real time, especially on their mobile phones, it's not something that you expect someone to be gathering one by one, pam, pam, pam. There's just like a technology that they've built that aggregates all the data and ingests it into maybe, for example, Uber's website or Uber's server, that the data scientist and whatever recommendation system or whatever algorithm or whatever machine learning or AI stuff they are doing to just make their processes better. So I just hope you understand what I'm explaining. Thank you. So apart from building pipelines, they are the ones that handle large data sets. Data is not usually in gigabytes format, it's usually in petabytes. And briefly, we are going to talk about what big data really means. I'm sure you'd have heard big data before. Big data, big data, big data, big data. So finally, one of the core responsibilities of a data engineer is to implement measures to maintain the integrity and security of data throughout its life cycle. You don't want it to be that the data you're gathering can be something that can be easily compromised. You get, like, somebody can just be somewhere and then just maybe do like an SQL injection thing and then start buffering your data from where it is. Like maybe the age, data to everyone these days is very priceless. It's not something that should be readily available to anyone. That's why there are usually sanctions to people whenever there's like a data breach. So the work of a data engineer again is to ensure what data flow. Not like as I said, it is automated. It's always going on back to back. If something happens to that process once, it's going to cost the company a lot. It's going to cause lots of issues, right? And again, security is also very important. You don't want it to be that the flow of your data, in the data pipeline is easily compromised. Do you get? So I hope that makes sense. So whenever we talk about data engineering, so there's something we call ETL. So ETL is either, you can either call it ETL or ELT. My time is just flying. Okay. So ETL process is just basically what is happening or from the source of where the data is being collected, processed, and then loaded into the database. So just think of it like this: ETL. E stands for extraction. T stands for transform. And L stands for load. To load means you are trying to load the data into a database or a data warehouse or whatever it is, wherever it is that your data is going to be used by the end user. So as I said, the ETL is the process of combining data from multiple sources into a large central repository. A repository is like a storehouse, like a storage house. Okay. Like a storage. Okay. Okay. So as I said, yeah, ETL means gathering data from different sources. Then as you gather from different sources, you load it, you transform it, and then you load it into a database where the end users can use it. So as I said, a common use case might involve collecting customer transaction data from a point of sale system. That's like from a POS system. Or, for example, I'm trying to even think of a use case that I think we should use for this. From, let's say, a POS system. Let's say you are working in Amazon. Like, the Amazon is big. Whenever you're in Amazon, almost at every point, people are usually buying stuff. So as you're doing that thing, you're buying from the customer directly, you're buying online, you're buying from maybe by the roadside, different sources of you buying stuff. At the end of the day, it's the work of the data engineer too. What's it? Yeah, exactly. And then I should just gather everything, make sure it is clean, make sure it is consistent, make sure that there is consistent data flow, and then ingest it into the database for whosoever wants to use it. So I'm getting short of time. I think I have less than 5 minutes, so let me try to just wrap it up. I was really thinking we were going to touch SQL today, but maybe in our subsequent classes. So as I said again, look at this first part is the extract form, extract place. That's where you have the databases, the files, maybe the file is in the data is in a CSV file. And as I said earlier, a CSV file is usually a structured data. JSON, that's the next one, is usually unstructured. Sorry, semi-structured. You have APIs. You can actually even get data from APIs, from this webbook too means like, there are some websites that you have to click something. This person's calling. You have to click something. Maybe you have to click a link before you can do any action. That's usually where the webbook application events is from. As you're doing all of those things, the data is being aggregated somewhere and transformed. The next part is the staging area. That's where the transformation is happening. And then finally, you load it into a data warehouse. That's the final stage. And that data warehouse, maybe the data analyst wants to pick the data to work with it. You can just go to data warehouse, select the table he needs to work with, select whatever he needs to work with, and perform his analytics. So let me just try to wrap this up. I think I've spent a lot of time here. Okay. So maybe I'll just try to also share this slide, or maybe in our other classes, we'll continue from here, most likely. So this is some of the, okay. I'm done, yeah?
Thank you very much. Good afternoon, everybody.
Okay.
It's a very big space, and if we continue, we would get tired. So I just asked him to take a pause here because I noticed we're all tired. I'm even tired. I came from another seminar to this one. So it's going to be for the entire year, till the year runs out, every Saturday for 12 p.m. Please clap for Mr. Jide.
Thank you.
He's my senior colleague, but I'm older than him. Okay, so I'm a data analyst by profession, and all of what he's saying took me forever to catch, and I spent a lot of money getting it. I was telling someone behind, I spent $40 every month for this course for 6 months, and that's a whole lot of money. So we had to bring him here to come and explain and teach. He has had time to touch the basics and then the advanced. He's with MTN as one of their data analysts in MTN. So he's a small boy, but he's a big man. So please, for today, we'll have to stop here because we need our brains to work next time. For next time, we'll touch on so many activities, go into deep practicals and all of that. The person that taught me, my very first data analyst explanation said, when you want to go out to a party, you would hear, let's go to an all-white party. You have the data, all-white party. In your head, what will I wear? You are processing the data. So when you decide to wear something of that same category, all white, you now come out looking different. So that is you assuming the data, the information, all white party. You wearing that all white outfit is you bringing the data into a visual form. There's a whole lot and it's still small. Then coming out is the end part of it. So we can have that to go all around. It's not all about data. We have a cybersecurity specialist in the house as well. We have a project manager. Same of all of them. I don't know why they did go that high. So, but then again, we have a lot of time to do this. But from next week, we'll have more practical classes, not just theory classes, more practical. So please come early. It's for 12 p.m. Come early, come with your laptop. If you don't have a place to charge, we can give you a power to charge. But come with your laptops from next week till the end of the year, every Saturday. And for this particular, I don't know if we can share the slide. Can we share the slides out? Okay, so we are collating data. We are talking about data now. The slides will be shared out to everybody, the videos, if you want it. If you want his contact, you can have this for more questions and their likes. So this is the tech hub of this church. It is for free. We're not charging anybody for anything. We're not asking you to pay anything. We just need you to show some level of commitment. Show up. if you show up, we'll give you all of what we have. Like he was saying, soon I will hear agricultural analysts. I've heard someone said it before, Sha, but I wasn't too sure. But then again, we are heading towards that direction. So thank you all for coming. You came early, that's why, sorry. Thank you all for coming, and I'll be so sure to see you guys next week for 12. Thank you very much. Please, before you leave, put down your details. We'll share out the slide if you need it. If you have more questions, you could ask any of us privately. We would answer. Thank you very much and have a good afternoon. Yes, madam. Yes, there is.
Thank you, everyone, for your time. Thank you.